Hey all, Grillo here with a guest. Welcome to this channel's first conversational video. I could not be more thrilled to introduce our first guest, Tyler of Clockwork Labs, who revealed SpacetimeDB 1.0 to the world a few weeks ago, which I then reacted to, and here we are. So welcome, Tyler. I'm so glad that you're here and are willing to take the time to chat.
Thank you so much for having me. It's going to be fun.
Yeah, I agree. So why don't you start by telling us a little bit about yourself? You're with Clockwork Labs. You run the place. You got like a lot going on. A new game, Bitcraft Online, a new database, SpacetimeDB. From your video, you seem pretty technical. Is platforms and backends, like, is that your thing? Like, where's your passions lie?
Yeah, I guess maybe I can start by just giving you some longer term background of where I come from. So
Yeah.
I'm a software engineer by background. I did my undergraduate in chemical and biomolecular engineering,
Wow.
which is weirdly related to games in a way that you might not expect. I'd be happy to talk about that later if you're curious.
Yeah.
And then I did my master's in computer science, and I was doing a specialty in machine learning and distributed systems. And then after school, I went to go work at Apple. And then from there, I went to go work at Machine Zone, which was a game company in their data science and data platform department. After that, we started a company. It was actually called Skylab, unrelated to Clockwork Labs' work, although it is the same actual legal entity. And then we got started on the game, and now here we are with a database as well. So that's kind of the long story, very short.
Wow. Awesome. Cool. So as I said at the start, on this channel, we did a reaction to the recent SpacetimeDB 1.0 reveal. And in that video, along with the commentary and thoughts, I had a lot of questions. And Tyler was awesome enough to jump into the comments and be like, hey, great questions. Happy to chat. And so that's what we're here doing today. We're going to dig into a bunch of the details. I got some questions. I'm sure we'll get into all kinds of stuff, but I'm ready to go. Are you?
I am ready to go.
All right. My first question is, so SpacetimeDB is very cool. I'm curious how y'all got there. Like, what did the journey of like deciding to create it look like? And kind of a side question is like, what came first, like the database or the game?
Yeah, bit of a chicken and egg scenario. I guess I would say so. It's a very long story. There's the shorter version, which is we just decided to build it for our game. But the longer version is that I've been working on this problem or variants of this problem for maybe more than 10 years now, if that makes sense. So let me talk, I suppose, a little bit about the inspiration for this. I guess the first inklings of wanting to build a system like this probably started it back in college. So I was working with my now co-founder on an app called Hungrosity, and Hungrosity was like you opened it up as an app, you clicked "I'm hungry," and your friends would find out that you were hungry. But we wanted to have invitations and friends lists and stuff in there. And that was back before there were things like Firebase, and there were things like GraphQL wasn't around. And it was a very complex permissioning system that you had to build. So you would have to build some access control list thing, and then you'd have to build in all the requests that your client was going to do, and it could never really stray from what you originally intended. And that was kind of the first time that I started to understand, like, okay, the current way of doing things does not really work. That's been, like, for social media apps, that's been improved a lot, I think, with GraphQL and some of the technologies that Facebook has created, and then also startups like Firebase and Supabase and so on. But then from there, I went to go work at Machine Zone, and Machine Zone made large-scale mobile games. I remember at one point they had like 100,000 installs an hour. And I think that was not on the high end. I think that was on the low end. So they were doing a lot of volume. And they always wanted to know the historical data because they wanted to predict based on it. So for example, they wanted to know whether a player like increased in power and then lost a lot of power in the game and that caused them to quit? Or at what point would they be likely to spend in the game? Or at what point would they be likely to help out a friend or that kind of thing? And they had sort of the old architecture largely, which is like, hey, we're going to use MySQL and we're going to have web servers. They were mostly PHP. And in order to get this historical data, they had a 20-person data platform and data science team. I think more than that at its peak. And they would snapshot the data every 12 hours. And it turns out that's a lot of data and also not great data. So it's a lot of data because 99% of the data in a database doesn't really change in a 12-hour period, right? So if you're getting 100,000 installs an hour, most of them will eventually leave your game, and you're copying all their data over and over again. So it ends up being huge, many petabytes of data. And then the other problem is, of course, you only have the 12-hour snapshot, so you don't know what happened in between there. So if somebody got destroyed and then left the game, you don't know exactly when that happened or what caused that. So that also led me to think towards when we were building our game, well, maybe we could build in some capabilities so that the entire history of the game could be recorded if we wanted to do data analytics. And there's a lot of questions around like GDPR and making sure that the data is anonymized and that you can delete it and all of that stuff. But that was kind of what was the inklings that led us towards down this path.
Wow. That's fascinating. Cool. And it makes me want, like, was there a starting point that wasn't SpacetimeDB? Like, what did you start with before you decided we just need a new thing?
It's a good question. So so you asked also what came first, Bitcraft or SpacetimeDB? Bitcraft decidedly came first. So we had no idea that we were about to embark upon building a database. We just wanted to build a game.
Yeah.
Let me talk about the game a little bit to motivate why it ended up turning into a database. So the game is a single world MMORPG where everything is mutable. So you can like raise and lower the terrain, kind of like Minecraft plus RuneScape, if you're familiar with those titles.
Yeah.
And you can cut down trees and your players move around, you build buildings in the world and so on. And because you can build buildings in the world, you can't shard it in the same way that you would shard other games. Because if I'm in, I don't know, Stormwind and I build a building, every other player needs to be able to see that building, or else we're not in the same place.
Right.
So that was a key component of the game, and we knew from the beginning it was going to be very challenging to build that, and we had not many resources. So a combination of necessity and naivety caused us to begin building a system that we felt was going to be easy to program, but that would also have the persistence architecture that we needed. So for context, we started by, we were going to look at Spatial OS. I'm not sure if you're familiar with Spatial OS, but it was a thing from Improbable, which was a company that raised $600 million to make these like giant world games. And it really had two problems when we investigated it. One was you didn't get persistence by default. So that meant that you're doing all the game simulation in the game servers, but we would need to write the system to write out all the persistence state if we wanted to do that. And then the other was you kind of had to pay the cost of developing a super large scale game before you even could start prototyping because of all the concepts that they built into it. And so we decided, well, we probably don't want to go with Spatial OS. And we began just building Bitcraft in the way that we knew how. We actually started using Postgres. So we thought, can we make Postgres dance in this way? Naively at first with TypeScript and doing connections over the network, and then a little bit with stored procedures. And then we realized, okay, well, we're going to have to do something else ourselves. And we didn't really even know it was a database, I don't think, at the time. And then eventually it became clear that it was a whole database.
Wow. Very cool. Something we talk about quite a bit on this channel is like dev teams and the amount of time it takes to build things. And so like from like inception to 1.0, like what was that time scale like and how many people did you have working on it?
It's a great question. the motivation for building this the way we did was really like designed around the fact that we had a very small team and we needed them to not be thinking about distributed systems. Like we couldn't go hire a bunch of specialists.
Yeah.
So at first, for the first year of the game's development, it was just me and my co-founder.
Okay.
I would say, I think for the next year, we were the only engineers. I think we hired one. I think we hired one more, maybe like 6 months into that, and he was primarily working on UI. And then we were building out the game. We had done play tests and all of that stuff. And so let's see, this would have been, so we started in 2018. And then in 2020, we grew the team a little bit more. So we had the one engineer and we had a few other people. And then in 2021, we released a trailer that did really, really well. And we raised a venture capital round based on that. And then we grew the team from there. So now the team, for context, on the Bitcraft side is about 24 people. I think it's about 8 engineers total. So mostly not engineers, like art and game design and so on. But that is sort of the timescale. So we've only really been a large team since late 2021. So really 2022, the last 3 years or so.
So the 8 engineers working on Bitcraft, does that include the engineers also working on Spacetime?
No, it doesn't. So
Okay.
We have another 14 people that are working on SpacetimeDB.
Okay.
But for context, we didn't hire any of those people until after 2021. So I believe, if I'm not mistaken, I don't remember exactly, but we had a system that we used internally called JankTimeDB, which was like SpacetimeDB, but it was the thing that I wrote before we had a proper query engine and all of these things. And that's what the game was running on. So this was after we knew it was a database, but before we had formally made it a product. And at the end of 2021, we started to hire people to work on SpacetimeDB itself. And that was really a process of turning it from JankTimeDB into SpacetimeDB.
JankTimeDB, that's great.
Yes. I lovingly. It was pretty fast. I mean, one difference is it didn't use WebAssembly. So it was like compiled into your application natively as a library. And it was okay. The query engine was big. Like that was a lot of pain for the game development team. So
yeah. Okay. Were there any like huge setbacks on the path from like JankTime to Spacetime? Or hurdles? Sounds like the query engine.
The query engine had to be written because we didn't. So let me I guess explain. I'll explain a little bit about how game servers and databases typically work. So in a normal system, you would have a game server in front of a database, and the game server has, let's call it, ephemeral state and then persistent state. And the persistent state needs to be synchronized with the database. Which means, by the way, you can't have anybody connecting directly to the database except the game server because your state will get out of sync. So you have to kind of hide the database away. It's owned by the game server. Essentially, that means that you're writing all of the logic that connects to the clients. So typically with a game server, you only write that logic specific to one type of client, which is your game client. And the server bakes in knowledge about who should see what data. So if I have a player here and a player here, I should say, oh, well, they're near each other, so I will broadcast that out to the clients. And so pre-query engine, if the game team wanted to edit what data the client could see, they would have to change the server code to make it so that the client could see a certain set of data. And then like sometimes that would involve complex logic because sometimes it wasn't based on position, but it was based on like, oh, if I have a chest that my friend knows about, then I have to know about it too, or something like that. And that would have to be sent down to my client. So they were writing all this complex logic. And then we could only have one type of client. And what the query engine allows you to do, it's kind of like GraphQL. It's the reading is driven by the client. And so you can have one client that's your game client. You can have an admin client. You can have a tree regrowing agent client that just listens to the trees and decides when to regrow them and stuff like that. So that was a big enabler for us. But your question about the hurdles and setbacks, I'll just address that as well. Moving from JankTimeDB to SpacetimeDB was a very large undertaking because everything was kind of being moved from the foundation. And I recall that when we first did it, we couldn't actually load, like for context, JankTimeDB could do something like 200 to 400 people in one physical server. And when we loaded up SpacetimeDB, we couldn't do one. We could barely get one person like into the game. It would take like a minute to load. And that kind of scared the game team a little bit. They're like, "Oh no, like is this WebAssembly? What's going on?" But the real answer is it just was not optimized. And we did some optimizations, and it went. It's now way faster than JankTimeDB ever was.
If I go back to the GitHub RIS, like I know SpacetimeDB is open source. It's public. It's on
Yes.
GitHub. If we go back far enough, can we find JankTime, or is that totally internal?
JankTime is actually built into the Bitcraft repository, so that is not open source.
Got it.
We have discussed open sourcing it. It's not something we're necessarily opposed to doing.
Yeah.
But yeah, it's not available right now.
Got it.
Sadly.
You mentioned like with JankTime, like the thing was like compiled into the application code or whatever, and this kind of goes to something I've been trying to like wrap my head around ever since I watched your reveal video. My mental model of SpacetimeDB is that more than just a database, it sounds to me like it's kind of like a serverless or cloud function like platform that has like persistence opinions built in that it makes available to that kind of hosted code. Is that the correct way of thinking about this, or am I kind of off base?
No, I think you're spot on. It's SpacetimeDB is meant to be servers plus databases combined into one system.
Okay.
I sometimes think of it actually more as like a distributed operating system than a database. So for context, if you look at the cloud today, if you open up Google Cloud Platform or AWS, you've got like hundreds of services that you can pick from, and you hook them all up, and you run Kubernetes, and you do all this stuff. And I fundamentally believe this is something we learned over the course of many years of trying to think about this problem. But I've come to believe that we really shouldn't be doing it that way. We should sort of think of the cloud as a giant computer in the sky, and that we take our program and we go run it on that giant computer. And that computer has a sophisticated distributed operating system that's able to schedule those programs to run on a particular machine and then execute. Kind of like, to be honest, like Erlang and Beam and stuff like that.
Okay.
So I think that's the correct way to think about it. You can kind of think about it as like Firebase, but more server driven. So like taking the logic that is often driven by the client in Firebase and loading it into SpacetimeDB. You could think of it like, so what's another interesting example?
I know in my reaction, one of the things I compared it to was like some of the work that Cloudflare is doing, because they're kind of taking that approach too, where they have like the durable objects, which you just kind of upload and you host them on like the Cloudflare platform, and they manage the proximity to data for you.
Yeah, so that's right. So it is similar to that as well. I think, though, the biggest difference between SpacetimeDB and probably that is it seems like, I'm not an expert by any means in Cloudflare durable objects, but it seems like they are trying to, like their first priority is the functionality and not the developer experience. Whereas for SpacetimeDB, a core motivation for why we did this at all was that it needed to be easier to do than the alternative, not necessarily harder, right? So you should have to know less, not more. And I don't know that Cloudflare has achieved that with durable objects, to my knowledge.
Definitely not. Like, if in my experience, it's still very much like deploying a server, and then you need to build the API on top of it. Which, that's definitely like an area. It seems to me like SpacetimeDB delivers in spades. So
yeah, I mean, it is fundamentally like it's really important that it's super easy to use. That's why, I mean, it was really critical that we had all the type generation. So for context, when you build a SpacetimeDB module, you've got all of your RPC calls essentially that are just decorated, and then you can just call them directly from the client. And all the types you use inside of the module we can also then take the schema of those and code generate them for your application. So it's kind of like protobuf in that way, but sort of built into your application.
Got it.
And
Also, kind of
therefore,
like
you don't have to build any of the
GraphQL, I
APIs.
guess. Yeah.
Say again?
Also, a little bit like GraphQL. I know like a lot of runtimes will take like a GraphQL query and they'll generate the types for that query in the client and stuff like that.
Very similar. So it's sort of similar like a GraphQL schema. In fact, we hope to be able to support GraphQL in the future. Like we chose SQL for compatibility reasons, and it fits really well for games. But there's definitely applications where GraphQL fits better. And if you're building a database, you can apply these different query models on top of them. So
awesome. You mentioned RPC there, so like the client is making an RPC call. So the thing that the client is calling, is that the reducer?
that is a reducer. Yes, they're one-to-one right now with API calls or RPCs.
Got it. Well, that slides very nicely into my next question, which was I wanted to talk about the internals a little bit.
Sure.
So is the way I described, like, I guess going back to my previous video, like I described the reducer pattern as like SpacetimeDB would take like a key or something that references like a record and along with some input, and then I'm imagining it works kind of like a reducer function in a language where you kind of take like the prior state, which would be the record in the database, you take the input from, I guess, like the RPC call, and then you run this function, you generate like a new output, which might be like an updated record or something. Is that kind of, am I thinking about that right?
You are thinking about that exactly correctly. I guess one thing I would amend is the key is not super important. The way we think about reducers, first of all, we stole the term from React Redux. So like that's where it came from originally. But the idea is you take state S and you have change C and you apply change to S and you get S prime. And so that's the idea, is you have the state of the database as it was at a particular point in time, and then you incorporate the new change that you want to make into it, and you get a new database state out. And you can kind of think of these discrete states. That's actually really important for games in a way that people often hack around, because in games you often want transactions or operations to happen atomically. So for example, if I'm trading to you, I want to delete the item from my inventory and add it to your inventory. And I certainly don't want to do half of that only. So I don't want to just delete it from mine, and I certainly don't want to only add it to yours, because otherwise we've duplicated items. And that happens all the time in games. So in SpacetimeDB, we felt it was really important that we never had to think about like not S and S prime, but like S corrupted prime where it didn't actually all happen. And that was key to the development of our game.
That's a really good example. I was just playing an alpha game the other day. I'm not even going to specify which game it was, but I was trading with one of my friends, and like there's some kind of a delay or something where like we traded them, like you could see it accepted it, and then right as it seemed to go through, my friend logged off. So they were like switching characters because they wanted like, and they came back and like everything was gone. Like, oh.
That is a classic problem in games, and databases have solved this years and years ago. It's just that we have to re-implement all of it in all the game servers, or otherwise don't, and just hope it doesn't have a problem. I mean, the classic one is gold dupe bugs that happen the following way. So you've got some code, and somewhere in your code, in your server, you're doing a trade operation, and a player figures out how to throw an exception in your code after you've added the item to their inventory, but before you've deducted it from theirs. And then they can just run that over and over and over again and make a million items. That happens a lot. That's a classic.
Very interesting. This is very educational for me, because like on this channel we talk about games a lot because I am a gamer, but I am not a game dev. And so like while like I can kind of conceptualize a lot of these things, like, but like yeah, like that exact thing that you just described, I wouldn't have known that. Oh, that's really cool.
But it's interesting because this is the type of thing that game devs have to think about, but they shouldn't have to think about. Like, this is why we wanted to build SpacetimeDB. It's like, you don't have to think about that. Don't worry about that. We want game dev to be more accessible. The dream of SpacetimeDB is that a single developer should be able to build an MMORPG. So we're taking it down from like 200 to 1. That is the dream. And to be honest, I don't see a reason why it shouldn't be possible.
Yeah, that's cool. Might even turn somebody like me into a game dev. You take this
Hope
far enough.
I'd be happy to.
um,
That's the goal.
Back to the reducer thing. So, like the way I described it and the way you confirmed, like that works for like one record. But I think in your reveal video, you were talking about a situation where like you could like mass update like
Right.
I don't even know how many, like hundreds of thousands of records,
A
like
million
super
in this
fast.
case.
Yeah, like so, like can a reducer impact more than one record? Do you have like multi-record reducers? Like, because that's
So
something like I have not done in Redux, but
it can. Well, I guess what I'll say is I don't remember. It's been a while since I've used Redux, to be honest. But
yeah.
um, the reducer pattern, it actually doesn't have to do with one record per se. I think a
Mhm.
lot of times it often does, but it's not required. So reducer is just I have state S, I apply some change, which can be arbitrary, deleting all of S, whatever it is, and I get to S prime, and I'm sort of reducing in these changes one after another.
Mhm.
And in our case, that can totally mean updating the positions of a million entities. So
Yeah.
that is the update. That's the change C, is like this new positions, and you then apply it to get S prime, and you do that iteratively to move things around in the world.
Cool. Continuing with this reducer thing, in your video, you mentioned modules. Um,
Yes.
so, like, I'm imagining like if this is like a distributed operating system or platform, like you were mentioning, and I imagine there has to be some kind of a process boundary. Or I would imagine like I can't just upload a million functions and they're all in the same process forever. Like, is there like a way that you're compartmentalizing this stuff like across processes? Is that at the module level? What does that look like?
Yeah. Okay. So this is a great question. You're asking in some sense, like, how can you um, scale this horizontally?
Yeah.
Um, and let me say how it is today, and then I'll talk about like what we're planning to do.
Yeah.
So today, in the released version of SpacetimeDB, you have one module which runs on one machine, and that module only executes within that machine. Now we have a clusterized version today, which allows you to run across a cluster. Sort of, it has a symmetric architecture. So if you talk to any node in the cluster, it looks like it's a giant computer that's made up of all the computers. And if you try to publish a module to it, it will schedule it to run on one of the machines, and then it also does all of the routing and proxying. So it'll direct you to the right machine and stuff if you want to talk to a particular module. But that module is a WebAssembly blob with a set of functions, a set of reducers that is running localized to one machine. So that's just something to understand there. We did that very intentionally for games because you want the latency to be very low. So if I was accessing the position table, the one I have in the keynote,
Hmm.
and I had to go across the network to go get a bunch of players, well, it certainly isn't going to take microseconds or nanoseconds per record. It's going to take much longer than that.
Hmm.
So it's very important that we allowed you to access in-memory data, like right next to the code that you're executing. Bitcraft already operates with a version of SpacetimeDB that does what we call intermodule communication. It's just like IPC, but it's in this case we call it IMC, but it's the same idea. You have one module running one process, and you can send a message from one to the other. So, for example, if I wanted to call a reducer on another module, I could send it a message, and then that would call that other reducer. These are not transactional. You could make them transactional with two-phase commit, but there's performance trade-offs to that. Another thing we could do in the future, but are not doing now, is, for example, having a table be distributed. So that would be partitioning the table or sharding the table, I suppose. And then if you access that table, we would either go get the data or we'd bring the code to the data and we would run the query, not the query, the actual reducer on the data across multiple nodes in a distributed transaction. That's very complex and not really that valuable for a game company. So we haven't really done that yet. You can do anything that you could do with that with the IMC way of doing it. IMC is very similar to Erlang for context.
Got it.
Does that answer your question, I suppose?
Yeah, I think it does, and I think it answers my next couple actually, because I was going to ask like what the data ownership looks like. So it sounds like a module runs on a computer today, and that module owns the data that is on that computer. And if I'm another module running on another computer and I need access to that data, I'm going through the IMC channel. What that sounds
That's exactly right. IMC, which is intermodule communication. And you'll be sending messages. Now, in the future, we can also do what we call IMS, which is intermodule subscription. So that is built on IMC, and it's just I can send a message, which is a query, and then that I will register that query with that other module, and it will send me updates in real time as they happen. This is what we already do with clients, so it's not really a stretch. It's just subscriptions instead of just to clients, but between modules.
That makes a
If that
lot
makes
of sense, and it reminds me of some of the work I've done. Call it event sourcing, like in
Mhm.
the Kafka world, where you have like two processes, and one process is kind of logging out what it's doing, and the other process
Is
is getting
listening and
updates from
processing.
that log, and so it's similar.
It's very similar to that. Also, like Apache Spark and Flink and stuff is a similar type of situation.
Hmm.
Um, so for context, this is what I worked with at my job at Machine Zone. It was with Flink and Spark Streaming and
Yeah.
Hadoop and all of that stuff. So you could, for example, with IMC, implement MapReduce, where you say like, oh, I'm going to send this request to a bunch of different mapper modules, which are then going to take the results and pass them to the reducer module. In this case, an actual literal reducer. Um, but uh, but yeah, that's very much the idea there.
So does
Um,
the IMC or does it use any known protocols, or is this something you've developed totally custom?
yeah, I mean, for the Bitcraft version, we just use WebSockets
Okay.
because it's fine. If in principle, if you're in the same machine, you don't need to use WebSockets. Use whatever transport layer. The transport layer is actually a little bit immaterial. You kind of want to use whatever the best transport layer is
Hmm.
for your particular use case. Um, for example, between clients and server right now, we only do TCP, so we only do WebSockets. But in the future, we could do quick, we could do reliable UDP, we could do unreliable UDP, although there's some details with that, so that you can play games to make the latency lower, maybe the throughput lower, whatever the trade-off may be
Yeah.
that you want. You can do that.
Awesome. So scaling is of extreme interest to me, and we've already started talking about that a little bit. But if trying to figure out how to phrase this, but like if my game or the application that I'm building is getting large enough, like knowing now that a module is basically equivalent to a server on SpacetimeDB, like would the pattern be like break your world up into multiple modules? Like I have this server serving this area, this server serving that area. Is that something that could work, or how would you approach this, or how are you approaching this in Bitcraft?
Yeah, so that's exactly the question. So we knew from the beginning this had to be scalable, and we wanted to be able to do that at the end, right? So that is, you've identified exactly how it works in Bitcraft. So in Bitcraft, there's a sort of a global um, module or database, as I'll switch to using the term database because the modules really we refer to just the WebAssembly
Yeah.
code, and the
Yeah.
database is the code plus the actual database. And the way it works in Bitcraft is we have a global database to check certain constraints. So, for example, like that all usernames are unique because, of course, you would need that.
Hmm.
Um, but it doesn't handle any of like the player movement or the trees or any of that per se. That's all held by a region database. And so we have, in the case of Bitcraft, a bunch of regions, and they all subscribe more or less to the global one to find out is there a new player, and then if there is, the global one will schedule them to a certain region, and then they show up in the world, and the client connects to that. So that's actually all pretty standard for how you would build a game like this in the past. This is how you would do it. You'd have like a global game server, and you'd have all region servers. So there's actually that's not a particularly innovative part of SpacetimeDB, at least right now. I think the thing that is cool about it is that because we've formalized all of that as a database, in the future we might be able to do some things that would do some of that for you. So you can imagine that, and we haven't thought super deeply about this yet because we haven't needed to. But you could imagine, for example, that we could do some kind of um, dynamic repartitioning of the players. So instead of you saying, "Oh, I'm going to send a message to move a player from A to B," that you sort of specify a set of predicates, and the database will automatically move that data around, so that you don't have to think about it. And so it's more like CockroachDB in that way, where maybe you have distributed tables, and the distributed tables are trying to locate data that's likely to be operated on by the same reducers into the same machine. And that's the kind of cool stuff that, like, well, it's really complicated, but it's possible because of the fact that we've formalized it in this well understood model of the world, if that makes sense.
That's actually really cool. And viewers of this channel, I think, will recognize what you're talking about. We spend a lot of time on this channel talking about how the backends of various games work, and
Mhm.
dynamic server meshing is kind of what you're alluding to here, which is something like Star Citizen is working on, and Ashes of
Exactly.
Creation, and some other games. And so, yeah, that's super
It's a
interesting.
really hard problem. If I
Yeah.
had to guess, like, what I can say is almost certainly true. Ain't no way that their dynamic server meshing is also keeping track of this positions persistently,
Yeah.
right? I doubt very greatly that that's happening. In SpacetimeDB, you would just get that for free, because it's just all of these processes do that because they're built on this framework, and that's the world that I would like to get to eventually. It's just easy. It's just easy to do it. And there's also steps along that way. I'll just point out as well. That's not like, hey, let's jump to the future world immediately. For example, I talked about MapReduce. Well, we could do different programming models that would allow you to sort of specify MapReduce without having to manually create the modules yourself. Right? So it's sort of like a higher level, not necessarily language, but configuration to be able to say, hey, I want to write this map reduction in the way that you might in Apache Flink. Another thing you could do, for example, is just do something a little bit more like Erlang, which allows you to have hierarchical actors. So a lot of the IMC and the inter-process communication, and I suppose also IMS, which is inter-module subscription, is inspired by the actor model. Are you familiar with the actor model?
Yep. Yep.
Like, okay, yeah. So it's got 3 rules, just for anybody who might not be. An actor has to be able to have an inbox, so receive messages. They have to be able to send messages to another actor, and they have to be able to create actors. If I'm not mistaken, these are the 3 rules of actors. So the one that would be really cool is if in your code for, let's say, the global Bitcraft server, we could spin out other modules or databases that would be handling other regions dynamically, like from within our code, and that then they would be children of that one. And so if the global one died, maybe all the children die as well, or they get disconnected, and so on. And that's very similar to Erlang.
Very cool. I think a lot of people of this channel would probably happy just to hear you say this is a very hard problem, because I mentioned all these games that are working on these problems of like dynamic meshing and all this stuff, but we have yet to see a game actually get it right. Like it's not in production anywhere yet. So
It ain't easy. It's not. It's not even close to easy. I think what's interesting is that, like, people, I frequently get the question, like, hey, is it a good idea to be building a database when you already have to build an MMO? But what I found is the answer to that is really that if you're building an MMO, you're already embarked on the quest of building a database. You just don't know it.
yeah.
Um, so it's already that complicated.
Yeah.
It's prerequisite,
Yeah.
and so it's kind of just along the way, is what I would say.
Yeah. Very good way of putting it. Back to some of the internal stuff. The next question I have is replication. Like, is that something like in innate to SpacetimeDB?
Yes. So the fact that SpacetimeDB is a database, again, we can then go and apply 50 years of research on databases. So in the cloud product, we do replication. So this is the thing that runs main cloud and the thing that runs enterprise, and it's just your standard log replication. So we have the write-ahead log, and we're replicating out. I shouldn't say it's just your standard. It's a little bit more complex than that because there's some real-world details to actually implementing this. But what we do essentially is, okay, we're going to get a little bit into the weeds here.
Yeah,
So,
let's do it.
Okay, latency is really important, right? For SpacetimeDB, you've got games, so you're trying to do like really, really low latency stuff. Databases sometimes have this concept of like synchronous commit, which is something that exists in Postgres. I don't, for example, know how CockroachDB treats that, or if they have a different thing. But what it means is that you are able to see the changes that have happened if it's on only after you know it's been persisted to disk, or it's been persisted to other nodes, or however you want to think about that.
Yep.
But the important thing is that it's a setting, and it's a setting actually per request. So it's not as if you always have to wait for the data to be persisted. It's like a spectrum. So you could say, for like durability, the D in ACID is kind of a spectrum. And so you could say, hey, I want to hear about the data as soon as the machine I'm talking to knows about it, but not necessarily when it's fully durable. Or I could say, hey, I want to wait for it to be written to disk. Or I could say, I want to wait for it to be written to disk on a majority of nodes in the replica set, and so on and so on. And so what we do is actually, for SpacetimeDB, because we're doing games, we by default have synchronous commit off. And so we actually deliver you the results of your data immediately upon it being added to them in memory. And so we can get super, super low latency stuff. But in principle, you could, for another request, just enable that, and then you wouldn't hear about it until it actually was replicated onto many machines. So for example, if I wanted to do like a money trade, I would probably not want to just be like, hey, I'll hear about it whenever, because there's both durability and consistency problems with that. Like if you do that and then your node goes down, well, none of the other nodes are going to know about it because you haven't waited for the acknowledgements.
Makes a lot of
Hopefully
sense.
that maybe answers your question.
Yeah, it does. I've heard that called like write concern.
Okay, yeah.
A number of other things. So, cool. Well, that leads me to my next question, kind of naturally, which was about persistence. You call the unit of storage tables. Like these are, but in spacetime, these are like, is there DDL that defines these tables, or is this like all in code, or like how's that work?
Yeah, it's a good question. For a long time, we weren't really sure if we should make it like DDL or what we do. It turns out the best user experience is to just say your module defines your database, and that we will define the schema based on your module. And if you want to change the database, you can change your module. And what this ensures is that your types are always in sync with what your tables are and what the types are that are in your tables. And it also means that when you spacetime publish, we can like diff the old schema and the new schema, and we can tell you like, hey, this is going to automatically update these columns or these rows or whatever it is. Or like you can't do this without deleting data or whatever it is. We can get all like the nice user experience from being able to store that in there. But not only that, it also means that, although I guess you could do this with a regular database, but we can scoop the, so we can like look at a module, just the WebAssembly module, and we can scoop out the schema from it, and we can code generate like after the fact a client for TypeScript. Like, so if you made a database and you published it to SpacetimeDB, I could look at your WebAssembly module and I could code generate a client for my client, and I would have all the same types because it's sort of built into the module. And that we've felt that that's very, very valuable. I think you could do the same thing with Postgres. You just have to use the meta tables as well, but it's a similar idea.
Got it. What does data migrations like if I'm changing the structure of my table in code, can I also like some kind of instruction for like how to move the data around to fit the new structure?
Yes. So if you look on our website right now, we have a recommended way of doing migrations, which is arguably the right way to do them or the better way to do them, but it's not maybe the thing that people think about. So the way we recommend right now is to do incremental migration. So this is like when your player logs in, you check a version number on their player, and then you decide if they're of your old schema, you route them and you update all of their rows into the new place. So you end up having like two tables, one with new players and one with old players.
Makes sense.
That works really well. Actually, we didn't even come up with that. That was one of our first enterprise clients said, "Oh, this is how we always do it because it's just easier down the road." However, we've also planned on doing like sort of the proper migrations that you would normally imagine. And the way this would work is you would spacetime publish. Certain things obviously don't change the schema. Certain things do change the schema, but we can do an automatic migration. So let's say you add a column with a default value. Well, we could just apply that and we could just fill in all the default values. And certain things require a manual migration. So let's say it really depends on what you want to do, but let's say I'm deleting a column or I'm just creating a new table and I'm replacing the old table. So it's just a completely new thing. What we want to do is code generate a function for you. So you can do spacetime migrate, and that'll look at the schema of your old tables and your new tables, and will output a script which you can fill in, which will go over every row in the table, and then take the old row and insert the new row.
Cool.
And you can just have that applied automatically when we upload.
Awesome. Continuing on this table thing, I'm curious, like when it comes to actually writing bits to the disk, is
Yeah.
that have you guys done all that customly? Are you using anything open source tooling off the shelf? Like I've worked with a lot of embedded databases myself, like
Yep.
RocksDB, SQLite. Are you employing any of that stuff, or is this all custom?
It's all custom. It's all custom. We've read a lot of papers about fsync. So I guess that's what I would say. So it's all custom, with the exception of with replication, we are using RocksDB and a thing called OmniPaxos, which is a replication algorithm. There is some discussion internally: do we want to use Raft, or do we want to continue with OmniPaxos? To be determined. But that's where RocksDB comes into it, because some details about metadata replication and so on. But other than that, like the actual message log itself, or we call it the commit log, the write ahead log, whatever you want to call it, that is stored outside of those things, and so it's completely unrelated to anything that's been pre-built. We were using Sled, but we had some trouble with that, and we ended up moving away from that.
Sled?
Sled is like a Rust embedded database.
Got it. Okay. What about limits? Like how big can your tables get?
Yeah, so good question. Let me talk about how the world is today and how I imagine it in the future.
Yeah.
Right. So today the world they have to fit in memory in principle, although you could of course just enable swap on the disk and then we'll start swapping them out. But they do have to fit on one machine, at the very least. And that makes them extremely quick to access.
Yeah.
And it also doesn't really restrict what you can do for 99.9% of applications, because machines have a lot of RAM these days. We run on machines in main cloud that have 256 gigabytes, but you could go bigger. There's a fun website called, I think it's called Does It Fit in RAM? Let me see what it is. Does it fit in RAM? Yes, does your data fit in RAM.net? And you can put in your data and you can find out whether it fits in RAM, and you'd be surprised. A lot of them can. So that's kind of where we are today. And then in the future, we would like you to be able to opt in to specifying that a table can be written to disk. And the trade-off there is you can have larger tables because they're going to be sort of negatively cached to disk. So negative caching is assume that it's always hot unless you sort of aren't using it, and then push it away to disk if it's not. And then eventually also maybe a distributed table. And so in that case, your table will be broken up and spread around the entire cluster. The trade-off there is that latency of access goes up considerably.
Definitely. I think that's a really good point about the large amount of memory in systems today. I mean, even the recent applications I've worked with, using things like Redis or whatever, you kind of want the same guarantee that the whole data set fits in RAM. So makes a lot of sense. But yeah, I can see some extreme cases where you'll want
I
the
can
other
definitely see extreme
functionality.
cases. Notably, you can always break it up into multiple databases.
Yeah.
It's more work, but if you're at the scale of needing multiple databases, then probably you can hire somebody to work on that problem. It is possible to do it. I think there is a lot of platforms that are kind of a dead end, where you are in that phase of scale. Maybe you have a startup and you're scaling your startup, and it's like it ain't gonna fit. It's just what it is, and you kind of can't. You're boxed in. You can't really get bigger. And there's a lot of solutions that try to paper over that and stuff. I think we wanted to design something that's like a clear out. Might be a little bit more work, but you can clearly do it in SpacetimeDB, and that's what intermodule communication is on our platform.
I know you made some pretty bold claims about performance on the reveal.
We did.
Like in my experience, like in order to like achieve the claims of some of these products and like actually realize them, like it usually involves some kind of like following some kind of a design principle or patterns that the system is good at. I know like I've worked with like some of AWS's products where like they'll say things like, well, we're really good at handling a ton of like small queries versus like the big fat queries. So I guess my question for you would be like, are there prescribed patterns in space-time to achieve these results? Or are there no-nos?
So the philosophy we have is fast things should be fast and slow things should be possible. So for example, if you put a big blob of like text data in SpacetimeDB, what we're going to do is we're going to convert that into a blob and then store it sort of like on the side as opposed to putting it in your tables. But what allowed us to get that result is, a transform or a position vector is 3 floats back to back to back. And modern CPUs operate well when you load up a bunch of things in cache and you just go over them because you've prefetched everything. So the mental model is instructions take 0 time, and accessing memory takes infinite time. And like then you need to make your decisions based on that. So what we did is we try to get everything out of the way for the simple case. So for the things where it's like, hey, I have 3 floats, and I have 3 floats, and I have 3 floats, and I have 3 floats in a page, we want to just wham, mem copy that into your module and then run over it super fast. And then wham, mem copy it back. You don't want to be poking around at indexes and things, which is what I suspect Postgres is doing. We tried a lot of things to try to make Postgres faster. We really couldn't get it. Maybe I failed at that, and there is some way. But I suspect what's happening in Postgres is they're optimized specifically for doing a lot of simultaneous queries that are all small. So they have a lot of bookkeeping for what's called multi-version concurrency control, or MVCC, involved with like, okay, well I have to set this, like, so for every row, right, where it's like X, Y, Z, they also have all this metadata associated per row with like what transaction that thing began on and what transaction that thing ended on, and you have to hop around in memory to update all of this stuff. And there are newer techniques that could make that faster. There's a database called Cicada, which is actually really fast at MVCC stuff. But it has a lot of overhead. And so I don't think we would beat Postgres if it came down to like as many small queries as you possibly could do. Like you're updating like 1 or 2 rows across many, many threads. I think that is where Postgres would improve upon us. That is not what most games do. It is actually what Bitcraft does, and I think we can do a lot better there for SpacetimeDB. But the answer is yes. The details absolutely matter, and I just think we can expand the amount of things that we're doing that are really, really fast as we go. If we're very intentional about getting unnecessary work out of the way and really caring about performance.
What are you measuring about performance? Like, is it the number of queries you can do per second? Is it reductions per second? Like, how are you thinking about it? Yeah.
So you kind of need to think about everything. So we measure, for example, the performance of the query engine. So a lot of actually the bottlenecking in Bitcraft is not doing the code that you have. It's actually evaluating all of the subscription queries to find out who should receive these messages, and then also sending those messages. So we benchmark all of that, and I'll have one more note about that as well in the future. But we benchmark all of that. We try to find out, what's going on there. We use like flame graphs are super helpful because we can just spin up Bitcraft with a ton of bots, and they're like doing stuff in the world and so on, and you get like really real world data on what's actually happening in the database. And we also do there's this amazing tool called Tracy. Shout out to the creator of Tracy. Which we use to do, it's like a frame debugger, so you can see like how long in time did this take. So it's not like a sampling debugger. It's like I am tracking time spans, and that lets us like really key in on what is taking a lot of time in the database. The only challenge with that is it's like a bit of a Heisenberg uncertainty principle because the tracing itself takes time, so you have to be a little bit cautious about applying it too liberally as well. But we measure everything from the reducer execution time to the host time, so the time that's spent in the host, to like index lookup time, to updating time, to committing the transaction time. There's some work that needs to be done at the end to commit the transaction. I think the number one thing about performance is that you measure. If you're not measuring, you're not really serious about performance.
You just mentioned something that comes up on this channel quite a bit, which is you mentioned spawning bots into Bitcraft
Yes.
and kind of measuring that real world performance. A lot of the games that we're tracking, a lot of people are like, "Why don't you use more bots or automation to test your performance?" And the response that we sometimes hear is like, "Well, you're never going to get as good of data as you can from like a real player." Like, what's your take on that?
I mean, I think that's absolutely correct. There's I don't think we could have built SpacetimeDB without Bitcraft. Like that has been an enormous asset to us because a couple of reasons. I guess the main one is really just the things that people think are slow are almost never the things that are actually slow when you measure them
Mhm.
with like a real world workflow. Because you know you're working in a particular part of the code base and you've forgotten about this other part of the code base, or it doesn't seem like it would be slow, but actually it is taking most of the time. So it's been immensely helpful for us to just say like, okay, we'll let's see how many players can we get chopping trees and walking around in the world and mining things in Bitcraft in like an actual use case. I think it's invaluable. I would encourage people to, if you're not building something on top of your own system and kind of dogfooding in that way, building a bot system that is able to do real world workloads. It's hard though. I mean, I'm not going to suggest that that's efficient.
Yeah.
It's a lot of work.
Yeah, my own experience says dog fooding is like invaluable. So
I think like I don't know that I've really had an appreciation for how important it was until we actually went through this. Like I think beforehand, before building SpacetimeDB and Bitcraft, I totally would have tried somebody else's product that like they had not built on. After it, I don't know. I don't know that I would have touched it because otherwise you're just running into all the problems that we ran into right
Mhm.
inside internally, and it's just there was a lot of them. I mean, there was one called this was part of the reason we couldn't even load one player into the world. There was a thing called schema for table. And you know, people were before we were measuring, people were all like, "Oh, well, I want it's got to be like, oh, we're copying data or we're doing this." But actually, what a large part of the problem was, for every row, we were calling this function schema for table, which would look up all of the schema in like the schema tables, and then like deserialize them out and rebuild them, and then apply it to read one row from bytes and then throw it away, and then do it again for the next row.
Yeah.
So it was like massively, massively, massively inefficient, and just nobody even knew because we didn't see, and then once we saw, we were good.
Wow.
I have a theory, which is that if we could just physically see with our eyes what most computers are doing for most of the time, it would be insanity. It would be it would be so silly. You'd be like, "What is going on here?" It's just crazy. Um,
I think about that all the time. I think that becomes more true with time too, especially like as you add layers of extraction and clouds and like compute becomes kind of nebulous and like in the old days it was like here's my computer that my program is running on and you're like and now it's just like well it's running somewhere doing something.
yeah, I mean, that's the thing is like with great abstraction comes great power and poor performance.
Yeah.
Because like I'll give you another example of something that was happening in the game. Right, again, the game team concerned, oh, the performance is bad. Well, we were doing pathfinding on the server, right? So we have these hex tiles, and we need to find out like, are you standing in water, or is there a tree there? So you need to route around it, or whatever it is. And the way this was working is the game team was storing the terrain data in chunks, so like big binary blobs, and they would in the module copy it over into the module, and then they would look up a particular cell's elevation, and then they would do their pathfinding calculation. Then they would throw it all away and look at the cell right next to it, which, by the way, was already in their data. And they would go get the same like 32 kilobyte blob and bring it back and then do the same thing. And they do that for everyone. It's like, well, if you could see with your eyes what was happening,
Yeah.
it would just be like, this is, of course, preposterous. But it's hard to see. It's just invisible.
Yeah. Are you working on? You mentioned like you're monitoring and tracking a lot of things in the performance of space-time. Is there anything you have that or you're building that allows you to see this stuff better?
I mean, we use a lot of open source technology to do
Yeah.
this. So like Prometheus is very helpful to get a sense of like real time as the game is running. What are the actual metrics that we're seeing? So we have dashboards that allow you to show like how long did this reducer take? How many rows is this adding? Is this deleting? How many rows are there in the table? How many seconds per second are we spending doing reducers versus like host calls versus like writing to disk or committing things? So you can kind of see like what is the maximum throughput that you can do. So are we writing our own stuff? Yes, insofar as we're building it into SpacetimeDB, but we do try to leverage as much open source technology as we can. In the future, we would love to store these metrics in space, like host them into SpacetimeDB, so you can just SQL query them, as you would anything else in your database.
Very cool. So in preparation for this chat, I reached out on the channel's Discord server and I said, hey, anybody have any questions for Tyler? And so I have a community question for you.
Oh, awesome.
Which is, what kind of hardware does it take to run the SpacetimeDB instance that powers Bitcraft Online today?
Yeah, so there's actually, you can use a lot of hardware to do this. For main cloud, we run on huge 80 core, 256 gigabyte machines with a lot of horsepower. But we also have a video on YouTube of us running Bitcraft with, I think, 500 bots on a Raspberry Pi. I think it was a 4 gigabyte Raspberry Pi, if I'm not mistaken.
Wow.
So you can do it. There's just not a lot of overhead for SpacetimeDB itself. It's a relatively small program. I think somebody did the math. It's like a couple, maybe like 20,000, 30,000 lines of code or something. I'm not exactly sure, but in that range. It's not hundreds of thousands.
So if a Raspberry Pi can handle 500 players, what can these beastly 256 gig 80 core machines handle?
It's a great question. They can handle a lot more subscriptions. So I mentioned the subscriptions are something that I wanted to talk about later. So basically, a subscription is interesting because if I'm a player and I'm moving around in the world, then for every action I do, n other players need to hear about it. And if all n are doing actions, then it's n by n. So you have n squared. And so there's a lot of techniques you can use to cut that down. Like if people have the same subscription, you can just evaluate them once and broadcast the message. And there's other techniques as well, but it's a nice problem insofar as it's trivially parallelizable. So you can run it across all 80 cores of the machine. And that is something that then goes much faster. But not only that, in principle, we could have replicas also be serving subscription queries with a slightly longer latency, and then spread it over many machines. More than any of that, though, it would be better to just optimize the subscription query code even more, because it's always better to not do work than to parallelize work that you never had to do in the first place. So,
yeah, I couldn't agree more about skipping work being like the ultimate performance improver.
It is. It really is.
You mentioned, so here's another thing you mentioned in the reveal. You mentioned upcoming compatibility with the Postgres wire protocol.
Yes, that's right.
Which I found interesting. As I mentioned in the video, the reaction video, I mentioned like it's cool to see like that becoming like a de facto standard. Like all these cloud database offerings are all kind of going Postgres wire protocol, which is really cool. Like I remember back when Postgres was like, the new kid, and now it's like the big thing. But I guess my question is like, where do you see that being used? Obviously, like a lot of the SpacetimeDB focuses on performance, super low latency code next to the data. So like, where do you see Postgres compatibility fitting in? Like, how do you see customers or products using it?
Yeah. So the first place and the most important thing that at least the thing that we get asked a lot is, hey, how can I have like a data visualizer? So if we do the Postgres wire format, the first thing is all your Postgres tools for connecting to your database will just work. So if you have like a database client that you use, it's like, bam, you're good to go. It will not, it's like not fully Postgres compatible. You can't, for example, do schema updates because we intentionally disallow them. You have to go through your thing. And then eventually the goal is that we will continue to add more and more and more and more Postgres support so that if we have a new client, we can onboard them by saying like, hey, this is a Postgres database. You can use it like a regular Postgres database. Or if you want to, you can put your own logic in there. And then they don't have to put it all in there all at once, but they could do it incrementally as they desired. And that is the motivation for doing that is there's so much stuff that's built on Postgres. Just let people use it. What I will say about that is there is a long, long, long tail of Postgres compatibility. It gets really weird in there. So like there's a whole object system and it gets whatever. I think we'll be working on this for years. But the first thing, the wire format, is pretty easy to do. And then you can get like 90% of the rest very straightforwardly. It's just when you get to like some very esoteric things down the line that it gets a little hairy.
I was just going to ask like how difficult it has been. Like I've never looked at like the wire protocol for Postgres, but it seems like it might be daunting.
I actually think the wire protocol not too bad, right? It's sort of just a binary format.
Yeah.
It's the daunting part is the long tail of arbitrarily weird Postgres features. And like all the historical stuff that like SQL has had to bring along to be compatible. That's more so. I'm pretty sure it was the CockroachDB team. I talked to somebody on there who I've mentioned CockroachDB a lot. It might have been DB. I think it was maybe Cockroach. And he said that they have, I could be mistaken, but I think he said they have an 80-person team working on Postgres compatibility. And I thought, oh, okay. And they've been doing it for like years. I might be wrong. It might be more like 20, but either way, it was a double-digit number of people just working on that problem over the course of like 5 years.
That's crazy. But I guess unsurprising.
Unsurprising. Nevertheless, like for 99, you can get to the again. It's really like a Pareto principle, 80-20 for everything we do. And you want to just get that 99% because you can get most of the people onboarded with no problem.
How does like how will a Postgres client see the SpacetimeDB data? Like it obviously you said like it doesn't support the DDL statements or anything like that because like the code and the code is generating the tables and all that. Like so like what will it see as like the table or the database? Is it all one just database and then just like all the tables across all the servers all in just one?
Yeah, so I mean, one thing I'll say is, I'm not working on this problem specifically myself.
Okay.
So I am not an expert in this, but my understanding is there's the wire format, which just specifies like the binary format that we're passing the messages across. So all of the messages we send back and forth will look like Postgres messages. It's just that if your client sends a message that we don't support, we're going to return an error. That's essentially. So if you tried to do a DDL statement, which you could do, you get an error back. If that makes sense. Does that answer your question?
It does. Here's one I have to ask. What may SpacetimeDB not be a good fit for? I think you kind of alluded to this a little bit earlier when you said about like some of the areas where Postgres might be a better fit, like on the massive parallel small queries things. But like, I know you probably spent a lot of time thinking about where it fits. Is there any place where it doesn't fit?
Yeah, it's a good question. I mean, obviously, we're trying to make it fit in the most number of places possible. And I would like it to work in that case. It certainly does work for the small query thing. I think I suspect that Postgres might do higher throughput. That's what I'm suspecting. But one of the places where like we are not going to be easier to use than something like CockroachDB is like, let's say I have just an enormous data set and I really don't care about latency. So like I have like, and I'm talking like terabytes and terabytes, petabytes probably. And I just want to say, oh, I'm just going to use a database and I just want it to be consistent across no matter where I'm talking. to it. Just use something like CockroachDB or TitaniumDB, or I call it TIDB, whatever the name of that is. One of these sort of new SQL databases, or Spanner, something like that.
Yeah.
Although Spanner's quite expensive, so get your wallet out.
Yeah.
So something like that. I think the other thing that on the other end of that spectrum, the thing that's a little bit tricky to do in SpacetimeDB right now, but we could do eventually, is like really, really fast-paced first-person shooter type things, where you have a lot of physics calculations, and you also want a lot of control over the network protocol, because you're doing very complex roll forward and roll back. We can do all of that stuff. We haven't right now, and so I wouldn't necessarily recommend it. Also, if you're using something like Unity or Unreal backend, you obviously can't run Unity itself inside of SpacetimeDB. So what you have to do is kind of run it as like a sidecar, and then publish the results of the physics calculations to SpacetimeDB, which then get replicated to clients. So that's a little bit complex, but it does solve a lot of problems that you might otherwise run into with Unity Cloud. I guess what I would say is we fail to a normal database. So if you don't want to use this for the modules, you can just use this for a regular database, and that's kind of the nice feature of SpacetimeDB.
Yeah. You just touched on like the thing I was kind of selfishly asking about. I mentioned about the combat thing and the reaction I did, and just the way you described the gameplay of Bitcraft. I couldn't help but wonder in the back of my head, like, is the architecture of SpacetimeDB somehow connected to your decision on like where to focus the gameplay on Bitcraft? And whenever you said, we're not super focused on combat right now, and you just mentioned like the physics calculations real time, so I was wondering if that kind of influenced the decisioning there.
Yeah, it's a good question. Like, did SpacetimeDB influence the game, and did the game influence SpacetimeDB?
Yeah.
It's hard to say, because it's been many years essentially since we were thinking about this. I think this is, if I had to guess, I think this is what happened. We knew we wanted to build an MMO. We knew that you need to have thousands of players in a single area.
Mm-hmm.
We knew that would be computationally expensive. We thought, so that's unrelated to the SpacetimeDB architecture. So we decided that we wanted the gameplay to be a certain way, kind of like a little bit like RuneScape, if that makes any sense. And that actually is what enabled us to even think that SpacetimeDB was a good idea, if that makes any sense. Or it was a weird idea, but it was like a not insane, like completely bonkers idea. And I think that it's more like the game influenced the fact that we would even attempt this. Nowadays, we could probably do a lot of what we decided we didn't fundamentally want to do in Bitcraft from like a gameplay perspective, because we have the performance and the capability to do it. So like in the keynote, I show you've got all these balls bouncing around and colliding with each other and all of that. And that is fully, like I said 60 FPS, but we could have done 120, and we can probably go way beyond that. So you can't, like, I would like to get to the place where you can do a first-person shooter inside of SpacetimeDB, and just have it be super, super easy. And that's totally achievable. I don't know that we're there today. People are trying it. Let me say this. People have done some really weird things in it that I would never have thought about. In our Discord, somebody implemented voice over IP over SpacetimeDB. So I just want to clarify what that means. They did a call from California to Finland in real time, synchronizing the voice data through a database. And it's like, it sounds like decent. You can find it in there if you want to include it in the video for people. But it's like, I mean, it's not great, but we haven't optimized it literally at all for VoIP data. So don't close your mind to the possibilities before you try it, I guess is what I would say.
I guess I have to ask, do you have like the whole history of the conversation?
We do. We have to. That's how it works. So,
that's how it works.
Yeah.
That's pretty cool. Wow. I'll have to look that up. Yeah. I might drop a link to that.
Testing. California to Finland. Test.
Hello.
That's pretty cool.
It's not too bad.
Not too bad.
I was a little bit blown away. I was like, don't do this to me, because now I'm thinking like, oh well, we could put like location-based voice data in Bitcraft, right, where you're like walking, you hear somebody coming from a distance, because we have all the location data, and we have all the voice data. We could have trees talking to you. We could have AI trees that decide to whisper to you when the wind blows.
I'm not much of a product person. I've always, I mean, other than like I like to productize backends and APIs and make them very user friendly, but someone who's working a little bit closer to customers, like one thing I've always heard is like it's not about saying yes, it's about saying no. So like, how hard is it like when people come with like these really cool ideas and you're like, wow, I never thought of it being used that way, to like not go off and like try to optimize for that?
Yeah, I mean, it's a lot of what we do.
Yeah.
It's like the most important role that I have is prioritization.
Yeah.
Because everybody has their own ideas of what's important and what they want to focus on. And engineers are incentivized to work on things that are fun and not necessarily the things that are the most useful to users.
Right.
And so it's my job to make sure that like we got to eat our broccoli as well as do the fun, cool things. And you know, it's you have a nutritious full meal, complete with dessert, ideally. So to answer your question, it is very hard to not be like, ooh, we could go off and do that now.
Yeah.
But we put it in a queue and we give it a priority,
Yep.
and it comes off the queue at some point.
Yep. So you mentioned Rust, C#. These are like the officially supported runtimes right now. Obviously, you're compiling the modules to like WebAssembly, and you're running them as WebAssembly objects on the platform. I know there's other languages that support WebAssembly well, like JavaScript and Go. Like, are you planning on expanding that list of supported programs? And what does it? Can you run unsupported? How's that look?
Yeah. So this is a great question. It actually ties really nicely into the last one. One of the beautiful things about open source, or at least working in the open, or allowing people to, in an open source way, interlink with SpacetimeDB, is that they can do the fun things immediately. Like they can just do VoIP. We don't even have to do anything. And to this point, I think somebody in our Discord already has Zig working for modules. So the answer is yes, you can totally do it yourself if you want to. You have to be a little bit enterprising, and you have to like look into our docs and find out how does the ABI from the module to the host work and so on.
Mm-hmm.
But people are already doing it. To your question about do we want to expand the languages, we absolutely do. That's like a very high priority for us, because we want as many people to be able to use SpacetimeDB as possible. We just have to be a little bit cautious about biting off more than we can chew, because we want to support these things properly. And one thing we did very early on, which was important but was a large burden, was supporting like multiple different languages. And then anytime, even when the API was always changing, we had to go through and update all of the different SDKs all simultaneously, and that was a lot of work and coordination between the teams. And I think I treated that more as, I assumed it was an easier problem than it was. And now we're trying to take a more principled approach to it to make sure that we can really deliver a super clean, super well-supported product in all the different languages.
Cool.
I would say that the like every third message we get is, when are you supporting C++ and Unreal? So that's a high priority for us as well.
Yeah, I can imagine. In the video that I reacted to, the keynote, you had a one more thing, or sorry, I forget how you described it, and I totally missed it in my reaction, because as soon as the screen went black, I cut the video. So I went back and I was checking that out. And I'm kind of jumping back, because we've already talked about the fact that SpacetimeDB tracks the history of state throughout like the entire lifetime. But I'm kind of curious, like, that seems like a whole lot of data to store. You kind of mentioned that all the data has to fit in memory, so I'm like wondering, like, does that include history? And like, how do you, like, are you employing any tricks to like optimize this, or like keep this like compressed?
Yeah, I got you. So first question, does it have to fit in memory? No, it doesn't. So the historical data doesn't go in memory, that goes on disk.
Nice.
It's only the current state of your application that fits in memory.
Yep.
So that kind of addresses some of that. And then isn't that a lot of data? I'll just address that broadly for a moment. Machine Zone, as I mentioned at the beginning, was storing all of this data, which had, petabytes and petabytes and petabytes of data.
Yep.
And almost all of it, certainly 90+% of it, was redundant data.
Yep.
Because it was data that didn't change, that they copied it all over and over again. So when we began this, we did a back of the envelope calculation, and it was just obviously cheaper and better to just store all of the data from the beginning if you ever wanted to do data science on any of your data. So let me start from that point. You can actually just do the math. Let's for example, let's say that you had 100,000 concurrently connected users who were all updating their transforms. So like the position and the direction they're looking 10 times per second for a year. How much data is that? It's about a petabyte of data uncompressed. Well, a petabyte of data uncompressed only costs about $1,000 in Amazon. Whoops, I think I lost my video. Oh, we're back.
You're back.
I don't know. So a petabyte of data uncompressed costs about $1,000 to store per month. Well, that is, that's at least 10 times cheaper than it would be to hire an engineer to try to go reconstruct the historical data that you were going to do in any case. Then once you get into compression, you can get anywhere between like 6 times and like 25 times compression on this type of data. So now you're talking about like, 50 terabytes or something.
Yep.
Instead of a petabyte. So now you're talking about like, instead of $1,000 a month, you're talking about $50 a month. Well, what are we even talking about? It's just not that much data. So a key part of it though is that the data can be compressed and archived and stored in a place like S3 for you to get it later. Or put it in Kafka or whatever you want to do to ship it around. And at your discretion, you can delete it. But the important point is you choose, not the system, right? So it's up to you to delete your data if you want to do that. And I think that is really, really, really important because otherwise, you're hiring a 50-person data science and data platform team to try to do this for you when you could have just had it for free.
Yep. Awesome. Sounds a lot like some of the things I've built with Kafka. I mean, it has a whole bunch of like history and topic controls as well. And
absolutely, cool. Kafka was a big inspiration for us as well. In fact, actually, I'll go back when we were using Postgres. We were keeping the message log. That was actually literally stored in Kafka. That's what we were doing.
There you go.
So we're using protobuf messages right into Kafka, and there you go. Boom.
So with 1.0 out the door, which has to be a huge like milestone for y'all. What's next? I mean, where do you see taking this thing next?
Well, we've got a whole roadmap of priorities that we want to cook on. I don't want to give away too much because we got some fun stuff. But I think the next part is, at the very least, let's address all the problems that people are having. Let's get more people onto the platform. I would really love, even if it's not us, the world to move in this direction. Like I just don't want to log into AWS anymore. I'm sorry. But I think that things could be so much simpler than they are today, and I really hope that that's the case. So should be fun. Should be a fun time. I can't wait to see what people build on top of it. They've been incredibly creative so far, and people send me messages all the time. They're like, "Hey, I've been trying to build this game for 4 years, and I just completely lost hope because it was impossible. But now with SpacetimeDB, I can see how I can clearly do it straightforwardly." And that's a very rewarding thing to hear.
I couldn't agree more on the general direction. I tried to kind of convey that in the video I did, which was like we've been moving to this for a while. Like I think like the code moving to the data is just in more and more different applications and scenarios just makes sense.
It does, and I will also add, we're not the first people to do things like this.
Yeah.
If we're adding anything, I think the main thing we're adding is like a hyper focus on developer experience. This should be the easiest way to do it, not the best way. I think it is also the best way, but the primary goal is to have it be the easiest way. Yeah. And that's been largely what a lot of the problems are with stored procedures and things like that. They don't offer an answer for scaling, and they're a pain in the neck to use.
Is there anything we missed? Anything you mentioned at the very beginning about how chemistry and biology connects to gaming?
That's a fun one. So maybe I guess we gotta give people that if they've stayed through the whole
Yeah.
talk. Okay, so chemistry and biomolecular engineering was my major, and let me just briefly explain what that is. These are people who work for like Merck, or they work for Budweiser, or they work for BP or something, refining oil. And what you're doing is you're analyzing chemical plants, or you're designing chemical plants, or you're trying to simulate chemical plants. You're just making chemicals, or insulin, things like that with biology. And a lot of what you're doing is you're looking at the population dynamics of molecules, or possibly bacteria, or what have you. And you're looking at that, how it changes as it passes through the system. So, for example, you might have chemical A and chemical B, and they combine to form chemical C, which combines to form chemical D, which then goes on to the next thing. Well, if you, instead of looking at your in-game economy as items and things, you actually think of them as chemical A and B, you can do the same math on all the chemical conversions. So if I craft an item from items A and B to make item C, and I then take item D and combine it with item C to make item E, I have very much the same population dynamics. And so a lot of what game developers talk about with like sources and sinks is stuff that is also very, very common in chemical engineering. So just to put a point on that, there is basically one equation that matters in chemical engineering. Every class that I did started with it, and it's in minus out equals accumulation, meaning if you have a closed system and you're putting stuff in, if it's not coming out, it's accumulating. Typically, accumulation is bad in a chemical plant because it means it's going to explode at some point, or burst, whatever is the situation. And it's largely true in games too. If you've got a whole bunch of items accumulating in your game, and you haven't thought about that, you have inflation, or you have economy imbalances and things like that. So you would like to design your game so that all the inputs eventually get sunk out of the game as outputs. And you can't always do that. So we have things in our game which we call sponges, which are not sinks per se, but they are able to absorb a lot of things over time. And it's just a weird way that the world is connected, and you wouldn't ever think about it if, I suppose, you didn't do chemical engineering and also design an MMO.
There you go. It is funny how these things connect. In some of my past videos, I've been like explaining something about like systems or whatever, and suddenly I realized that like this is kind of how like a black hole works. Just weird stuff like that. So I get it.
Yeah. It's very similar. I mean, SpacetimeDB is definitely a black hole for my time and my effort. It sucks it all in, but it's really cool. So I'm really excited to see what the future holds.
Amazing logo for SpacetimeDB, by the way.
Thank you.
One last question: how's Bitcraft going? It sounds like you have a bunch of beta players or somebody in there like testing things out. Like how do like when is there going to be a phase in the near future where more people can get involved?
Great question. I'm glad you asked because it allows me to plug it. So we've had like 1.8 million real people signed up to play the game. We have all their emails. We also have we just released the Steam page the other day, and we have about 75,000 people signed up to play with wishlisting that. So if you're out there and you're interested in playing this game, go ahead and wishlist it on Steam. It's called Bitcraft Online, and we would love to have you. And then on May 29th, we're going to be going into early access, so you'll be able to play then.
Amazing. I'll definitely sign up. So speaking of plugs, is there anything else you want to plug while you're here? Like how do people get to find out more about Spacetime? Download that. Yeah,
so go to our website, SpacetimeDB.com. Definitely join our Discord. So we're happy to answer any questions you might have in there. There's a lot of things. It's a fundamentally weird idea, but I think it's a cool one. So if you've got any questions about how it works or how you can build your applications, go in there. And on the website, if you want to schedule a meeting with me, there's actually a button to do that. So feel free.
awesome. Yeah, this was super awesome, amazing. Again, thank you so much for taking the time to do this. I certainly
Thank you so much
know.
for having me.
Yeah, definitely. I know a lot of people that watch this channel. They're going to really enjoy this. I did certainly know a lot more than I did an hour ago. This community is an interesting mix of like gamers and technologists and stuff. So yeah, I think this is going to resonate well with everybody. So everybody watching, go give a like or a thumbs up or a GitHub star or whatever it is to the sites that Tyler here is talking about. Yeah, very cool.
Thank you so much, and excellent questions as well. I really appreciate it.
Yeah, so we're going to cut it off here. Thank you everybody for watching. Take care. We'll see you all again soon, and we're out here.